Hello everyone, let's continue our learning of OOP, and today we're gonna talk about inheritance. In other video about encapsulation I already told all about this repository and the link in description, just check in the bottom of video. Okay, let's go to examples without wasting time. Let's close this for now, and we have inheritance folder here, like in our repo, and here we have Rust, Python and TypeScript example. Just what you want. Let's start with TypeScript, flowers, and it's really easy. I am not gonna analyze all syntaxes, cause it's gonna be a long video. I'm just do this: class flower, class rose, class lotus, class kaluna, and it's look like this now. And I think you already understand what's happening here. Inheritance is just inheritance. You have plants, and you have a class plants. It's JavaScript logic, and next you have a flower class who extends from a plants. Yep, and look, your attention, in the class plants you have a color. It's green by default because many of plants is green. Life, how you know plants is life? When it's not dead, obviously. And danger false. I thought that more plants is not danger by default. Here we have some base examples, some base methods or best traits, if you want, of plants. Now we have flower. Maybe you want maybe you want to imagine it's like flowers. Oh, okay, I'm press Ctrl S, and it's all gonna blow up because of ESLint in the VS Code. Where it is? It's here. How you can off it for now? Okay, I don't want to turn it off. I'm just don't gonna press Ctrl S. We have here flower, extend from plants, and nectar source here is false. Nectar source, it means that bees can be how I can say it, it's English. Let's wait a minute. It means that bee can pollinate this flower, and I'm type false by default, but I don't know, maybe more flowers can be pollinated in our world, but okay, let's work with false by default. And here we have another classes who, pay attention, all extends from a flower. Flower, 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 extends. Class rose, class lotus, class kaluna. Here we have a color like in plants, but we have a color of rose red, color of lotus is pink, and kaluna color is bright pink. And rose danger is true, but it's really not. It's just for example. You know, rose have some I don't know what it is, but some kind of some kind of spikes, and it's danger, really. And kaluna have a nectar source with equals true, because bee can pollinate kaluna. Maybe you know that. Okay, it's all just inheritance. We extend flower from plants and extend all these traits of plants. We extend default nectar source from our rose from flower, from our lotus from flower, and in Columna we make some difference in nectar source because it's becoming true here. And pay attention, we change the color of the every flower in here, rose, lotus, Columna, but in class flower, where we extend it from a class plants from class flower, it's not color, but here we have it. It's because it's multiply levels inheritance, and you really can make it more deeply. Let's make some more deep level. Why I can't copy it? Oh, okay. And another level of extends from rows. Let's write it like that. We extends white rows. I hope the roses I hope that roses exist. Color is white and danger is, let's type it false, but I don't think that it's false. And how you understand, now we have a new 4-level class, white rose, who extends from rose. We don't need this danger here. Its class extend from rose danger, true, and its color is white, like not in all more popular roses. Yep, it's inheritance. It's just biology or botanica. I don't know how botanica is. Maybe botanica is botanic. And let's run this code, but you don't see here some cool features. We just have here multiply level inheritance, rose, color is red, a danger true lotus, and pay attention on this, on blast. Here we output our lotus in console, false, it's a danger of lotus, color pink, yeah, it's here, color of lotus is pink. And now console log lotus is live, my object live. This is a live plant. Remember, don't forget that we don't have life in lotus, we don't have life in flower, we have life in the plants. And it's already in all Columna, lotus, white rose, rose, flower, it's already life in here. Life method. And it's inheritance. Okay, I hope it's you understand what it means. Let's check another examples on another languages. Okay, let's save it. And now let's check Rust and on the last Python with some big example, but easy to understand. Rust. Here we have our entry function main. If you're familiar with Rust, you know that function main it's some kind of index in JavaScript. Without main, Rust code don't gonna be work. And here we have some trait, quack, some struct, duck, and some implementation, quack for duck, where we give a function quack for our duck. And we have struct, another struct, not like duck, it's a random bird, You can just imagine that struct it's something like interface in TypeScript, but it's really not like that. Just imagine it. And we implement quack for random bird. Yep, you can see that we implement trait quack from duck and random bird, and here function quack like here, but wait a minute, but here we have some extended logic. If self is a parrot, print quack like here, but else print in a console I'm a parrot lagger. Maybe you remember from here from Aladdin. Okay, continue. And now we give some variables, duck1, duck2. Duck1 just give us a duck implementation, and struct duck with implementation quack, it's just quack. Let duck2, it's random bird, but it's not parrot. Here it's this logic. And let parrot variable random bird with boolean is parrot true. It's this logic. Okay, let's check it out. Yeah, we have a vector. It's syntaxis of Rust. Vector ducks, where we gonna through all this vector. It's not array, it's vector. How you understand? Okay, Control Alt N, and now we have our console log here. Quack quack, and I'm parrot lagger. We just output all our member of vector in console, and these two duck1 duck2 is quack, and last vector parrot is I'm a parrot lagger. I think that's already understand what is happening here. We just inherited quack trait from duck and quack trait from random bird, but outside of quack we have I'm a parrot lagger too. It's really equal to polymorphism here, but we can implement this for inheritance too, because it's a struct duck and random bird, and we just inheritance struct of random bird from quack and duck. I hope it's understand, but I don't understand what I say too. If you in some kind of weird condition here. And let's check last example. Yep, Rust, it's really hard language for OOP, object-oriented programming, because you can see here that we implement quack for duck and for random bird, and it's really not in OOP style. Every time write implementation and other. Oh, I don't need this. Okay, Python on Blast. We don't gonna analyze all the syntaxes, of course. I'm just want that you pay really close attention to the getter and setter here. Maybe you're familiar with this syntax getter setter. It's just some kind of how I can say it, some kind of logic what people do it from themselves. And in Python here you have some employer and some manager class, and pay attention that manager class it's inheritant from employer. Yep, inheritance logic in Python looks like that. Class manager employer, just in brackets. Okay, in employer we have some definition, self, name, title, name and title. Pay attention to that. And in a manager we don't have a definition of name and title. We just have some super init name title, and we don't have this getter and setter too. Pay attention to that. We have this get reports, definition pay per year. It's all method or function. And another logic of manager. It's don't really have a matter for us. Here we create these objects, and let's just run code and see what it gives us. Ctrl Alt N. Now you see code here. Employee name John Schmo, employee name Chris Smith. It's employee 1. It means that it's object. It's just a convention. Yeah, convention, like convention in a getter setter. I can't remember what it's sound like. Okay. Employee 1, employee 2, manager. How you can see, we have Joe Schmo Pizza Maker. Pizza Maker, it's title from them, and Chris Smith cashier, and manager Sue Jones Pizza Restaurant Manager. It's manager have a title and name too, but in our manager we don't have getter and setter for get name and get title. But in a console output you see that our manager have a name and have a title here. It means that logic of a getter setter work in a manager class because of that logic inherited from employee. It's all. Yep. You don't need all this syntax to understanding inheritance. You just need to understand this part. And that employer give manager from inheritance getter and setter, get name and get title. Without this inheritance, our manager cannot have a name and cannot have a title for his job. It's all. I hope that inheritance is understand for you, but if it's not, let's just make some brain experiment. Look at your window. If you have windows in your house, I hope that yep. Look at your window, and here you see some kind of plant. Yep, some kind of plant. It's a green plant, I hope. If it's summer, or it's some just some plant without green color. It's plant, and now thought about what plant it is. It's tree, it's flowers, it's brushes, or what it is. Okay, it's tree. You see tree inside of your house through your window. And now my next question: what tree it is? Let's think that this tree is a I don't know what this tree is. Tree picture. Let it be a leaf tree. Yeah, but I think you don't see this tree through your window like I am. But just imagine something like that. You see a leaf tree through your window, and it's multiply level of inheritance. It's at first it's not even plant at first. At first it's something. It's some kind of thing. Some kind of thing. Plants. Some kind of thing extends of plants, and its plants is free. It means that plants that tree extends from plants, and this exact tree is olive tree, and this olive tree extends from a tree, just from tree, and it's all inheritance. It's all what you need to know about it. Okay, I have some strange feeling in my throat, so let's over here. I'm gonna drink water and we're gonna talk about polymorphism. Bye.